Welcome back. I hope you have all installed GHC and have played a little bit by typing in expressions. What we're going to do now is we're moving beyond simple expressions and see how we can load full Haskell programs into GHC. And in Haskell, programs are not called programs. Typically, Haskell people refer to their code as scripts. Because Haskell programs are maybe shorter than normal code. I just call it Haskell programs, but the Haskell parlance is scripts. Okay, so new functions, if you want to define a complete Haskell program, you define them in a text file that contains a list of function definitions. And this text file has a suffix .hs that indicates that that's a Haskell file. Just like an HTML file has an .html suffix, or CSS file has a .css suffix, or a Java file has a .java suffix. A Haskell file is called whatever.hs. Okay? So it's not mandatory, but it's useful that you can see when you list the files in your directory that you can see that this is a Haskell script. Now, when you are using GHC, what you do is you edit your script in one window using whatever editor of choice. And then whenever you make a change, you load the script into GHC and kind of start executing expressions. So that's the kind of workflow that we will be using for most of the course. So for simple things, that's what you do. Of course, when you're building commercial Haskell applications, this is not what you do. You will compile them into standalone executables. But for the purposes of this course, this is the workflow, okay? So we have the editor window open, we have GHCI interpreter open, and then we will load the scripts. So in this case, we will create a text file, test.hs, and in there we put two function definitions. The first one, double of x equals x plus x. That's what it promises. And then we can quadruple by calling double of x. Okay? So we save that file, and then we start GHCI and invoking it with test.hs. And now both the Haskell standard library and the functions, quadruple and double, that we defined in the test.hs will be available. So for example, we can call quadruple of 10, it will return 14, but we can also still call all the standard library functions. For example, we can take double of 2 of this list. Well, double of 2 is 4, so this is the same as take 4. Is that correct? Yes, so we take the first 4 elements of the list. There you go. So now what we do is we just leave GHC open. We return to our editor. We add 2 new definitions. One is factorial, and the other one is average. And since we're starting here, I have to, we're using some syntax that we haven't introduced yet, so bear with me. So product of 1 to n, this thing here, denotes the list of values 1 up to n. And then product is the function, standard library function, that multiplies all the values in a list. So this is a good definition of factorial. And then when we want to calculate the average of a list, what do? We sum all the elements, the values of the elements, and we divide that by the length of the list. Now, of course, this is not a very smart implementation of average, but that doesn't matter. We're not here to define average. We're doing this to learn GHCI. But the thing that we're using here is this trick here in Haskell is that when you put a function name between these single back quotes, it becomes an infix operator. Okay? So if you write x, back quotes, f, y, that's really just syntax sugar for f, x, y. Okay? And some people like this thing as an infix operator. Some people like it just as a regular operator. It's your choice. But this is syntactic convention. So this is not a string or anything. It's really taking a function and turning that into an infix operator. Then in GHCI, we call reload, and it will read the file test.hs, add all the new bindings that we just defined. So that was for factorial, so we can now call factorial, and then we can call average as well. So, and here you see the workflow. So you have your GHCI open, your editor, you edit, you call reload, and then you can try your code out. A few syntactic things, oddities in Haskell. Functions and parameter names must begin with lowercase letters. Okay? So if you define a function, it must be, of any of this form. But you see any of these starts with a lowercase letter. And you can use regular quotes if you're kind of too lazy to invent a name. So that's something that I often miss in other languages where I just want to say x prime, x double prime, etc. Okay? And if you define a type has to start with an uppercase name. And that's the kind of reason. So in Haskell, the types and identifiers are in different namespaces, and that's determined by whether it starts with a lowercase or an uppercase identifier. So that can be confusing if you come from a different language like Java or C# or JavaScript. Then the other thing is that in Haskell, we use a kind of very mild form of Hungarian notation. So if a parameter has an s suffix, so for example, if you have a parameter named x's or n's or n's, that means a list of values of type x. And this is a list of values of type n. Sometimes the n doesn't correspond to the type name, but typically when you see an s at the end, you know that it's a list. And if there's two s's at the end, like here, you know that it's a list of lists. And that's convention. So if you want to look like a real Haskell programmer, you should always use this convention. When the parameter is a list, it always ends with s. And usually, Haskell identifiers are short. So you don't call it elements, you call it x's. Another interesting thing that Haskell has in common with Python is that white space is significant. And the exact rules are quite subtle, but again, we are just, using Haskell in very simple ways. So this is kind of sufficient. So if you have a sequence of definitions, like here, they all have to start in the same column. So you see here, A, B, and C all start in the same column. In this case here, B has a space to the left of it. So now all these definitions don't start in the same column. That's wrong. Or in this case, C and A don't start in the same column as B. Also wrong. Okay? So white space is significant in Haskell. So make sure that all your definitions are lined up. This is called the layout rule. And the layout rule, again, is there to avoid writing unnecessary syntax. So Haskell folks like to write this. So A equals B plus C, where, and then in the where clause, you have a list of definitions that all start in the same column. And then D here starts in the same column as A. So that belongs to the same group as A. And you can write this with explicit curly braces and semicolons if you want to, but that looks a lot more verbose. Okay? So Haskell programmers like brevity So they often use significant white space, and this looks a little bit like clowny. In the Haskell world, when you write code like this, people will kind of look like, didn't do enough wax on, wax off. All right. Here's some more GHC commands that are useful, and I really invite you to play around with it. And when you do the exercises for subsequent lectures, make sure that you leverage GHC or whatever other compiler you use to help you. Okay, so we have seen reload. You can also just load a script. It's a fresh script. You can, from the interpreter, open the editor. So you can edit a file with a certain name or edit the current script. This one here, super useful. Give me the type of an expression. I do this all the time. Never write types myself. I ask what the type is, and then I go in the editor and paste in the type. And you definitely should use colon question mark, and that gives you a list of all the commands with a small explanation. And of course, I hope that you will not use this last command to quit GHC, but that you will kind of, for the next 8 weeks, you will be constantly using GHC. Okay, so there will be a lot of exercises. The exercises will be on the website, and all these exercises you should be able to do them in any language. So you don't have to use a GHC, but in this case, since this lecture is about GHC, they will be GHC specific. All right, but in general, as I said in the very first lecture, this is a course about functional programming. It's not a course about Haskell, and it's definitely not a course about GHC. But in this specific case, the exercises for this chapter, for this lecture, are on GHCI. Okay, happy hacking, and see you all next week.